Say whether the L'Hopital rule applies. If it does, use it to evaluate the given limit. If not, use some other method. The L'Hopital rule can be used for indeterminate form only. The indeterminate forms are 0 over 0 or infinity over infinity. This can be plus or minus infinity over plus or minus infinity. The sign of the numerator and the denominator do not have to be the same. For part A, we first evaluate this expression to see if it is in indeterminate form. If we plugged in -1, this is not the limit yet, but if we plugged in -1, we have -1 squared plus 3 times -1 plus 2 over -1 squared plus -1. This is positive 1 minus 3 plus 2 over positive 1 minus 1, which is 3 minus 3 is 0, 1 minus 1 is 0. So yes, it is in indeterminate form. If it is indeterminate form, we can use the L'Hopital rule, the limit at x equal to -1. We then take the derivative of the numerator and the denominator separately. The derivative of x squared is 2x, the derivative of 3x is 3, and the derivative of 2 is 0. In the denominator, the derivative of x squared is 2x plus the derivative of x is 1. And then we checked again to see if it's in the indeterminate form. If we plugged in 1, 2 times -1 plus 3 over 2 times -1 plus 1. This is 3 minus 2 in the numerator, which is 1, minus 2 plus 1, which is -1. It is not in the indeterminate form. We only do that just to be safe. Now that we have new limits, we simply first plugged in the number to see if it gives us a real number. This function is continuous on its domain. The domain is the set of real numbers that are not -1/2 here, because if x is -1/2, then the denominator will be 0. But this limit, x does not go to -1/2, so we can simply plug in the number and find the limit. 2 times -1 plus 3 over 2 times -1 plus 1, and we saw that this is 1 over -1, and so the answer is -1. This is the limit of the original problem as well. For part B, we proceed to check to see if this is in indeterminate form. We plugged in 0, and we see that this is 0 cubed plus 8 over 0 squared plus 3 times 0 plus 2, which is 8 over 2, which is not in the indeterminate form. And so the limit is 0 cubed plus 8 over 0 squared plus 3 times 0 plus 2, which is 8 over 2, or simply 4. In this case, the L'Hopital rule does not apply because we checked it and it is not in indeterminate form. For part C, if we plugged in a very large negative number, because x goes to -infinity, then we would have 10 times a very large negative number plus 300, a very large negative number plus 1 over 5 times a very large negative number plus 2. 10 times a very large number is still a very large number. 300 times a very large number is still very large. 5 times a very large number is still very large. The first term in the numerator is positive because a very large negative number squared is positive. The second term is negative, but we cannot say that a positive infinity plus a negative infinity is 0. That is in indeterminate form. But at least we see that in the numerator, it is a number that is very large over in the denominator large as well. We don't have to worry about the sign for now. And so we can use the L'Hopital rule. This is the limit at x go to negative infinity of, in the numerator, the derivative of 10x squared is 20x plus the derivative of 300x is 300 plus the derivative of 1 is 0. And in the denominator, the derivative of 5x is 5 and the derivative of 2 is 0. This is now the limit at x go to negative infinity of 2x plus 300 over 5. Now, at x go to negative infinity, 2 times a very large number is a large number, and in this case negative. And a very large negative number plus 300 is still a very large negative number. And so the numerator is a very large negative number and the denominator is 5. A very large negative number divided by 5 is still a very large negative number. This notation doesn't mean that the limit exists. It shows that this limit does not exist in a special way. Remember that infinity is not a finite number. In this case, we say that the limit does not exist. But again, it does not exist in the special way.